Okay, so if I said I want you to find the critical value for a right-tailed test with n equals 30 at a, let's just say at the alpha equals 0.025 level. So let's assume we're talking about a population mean here. Anytime we're talking about the mean, then we are looking for the t value. So we're looking at our t distribution. When you look at this t distribution, it's set up a little bit differently. Okay, it's still a normal shaped curve. Down the side of your table, you have the degrees of freedom. How do we get degrees of freedom? N minus 1. So my degrees of freedom, n minus 1, would have to be 29 here. All right, across the top, we have the probabilities. Okay, so that's my alpha, my 0.025. When I ask for the critical value, I'm asking what t is. We want a right-tailed test. So we're finding, essentially what it tells us is the area right here is 0.025. I want you to tell me what this t value has to be. So you go to your table, you go down to 29 degrees of freedom, you go over to the 0.025 probability, and so the critical value, that's the t, is what? So that is the answer I am looking for. Let's try some. I'm not going to write all this out. Can I just assume find the critical value for a left-tailed test with n equals 7 at alpha equals 0.01. So the picture, not necessarily something you would have to draw just to find the critical value, but I think on some of your homework I did ask you to draw a picture just so you're kind of understanding this. When I said left-tailed, that's down here. Okay, so I'm giving you that this probability is 0.01. We have to figure out the t that would be associated with it. How many degrees of freedom do we have? N minus 1, so 7 minus 1 is 6. So when you go to your table, if you look at the top, this table is set up for the right. How will my t value be different if I'm talking about the left? It would be a negative, right? Just like the normal, this is centered at 0. So I know since this is left, this would be a negative right here. So we go to 6 degrees of freedom over to the 0.01 level, and the t is 3.143. So this would be a negative 3.143. All right, downsides of this, obviously we don't have every possible degree of freedom and every possible probability, but we have some available to us. Let's do one more. So find the critical value for a 2 two-tailed test with 24 degrees of freedom at alpha equals 0.1. So if it's two-tailed, that means you have to find two t-values. What would be true about both of those? They're the same except one's positive and one's negative. Okay, if my alpha is 0.1, I have to divide that between the two tails. So each one actually has a probability of 0.05. I did give you the degrees of freedom, so you are looking up 24 degrees of freedom, but the alpha you're actually going to look at is 0.05 because we had to split that up over the two tails. So 24 degrees of freedom at 0.05, and it tells us 1.711. So this would be a negative 1.711. Or you could just say t is plus or minus. And again, we had to have both because it was a two-tailed test. So there were two t values that we had to find. Does that help? Felt like we were a little rusty on that. Did everybody find these values in your tables when we were going through them? So I want to, when we go through examples today, I may add in another extra example, and I want to kind of talk about how we will read these from our table, as well as talking about the calculator portion. So I think we are ready for example 2. Alright. So according to the United States Mint, quarters weigh 5.67 grams. A researcher is interested in determining whether state quarters have a weight that is different. He randomly selects 18 state quarters, and weighs them and gets the following data. So a little bit different than the other examples in that I'm giving you the actual numbers, not the final mean that he had. At the alpha equals 0.05 level of significance, is there evidence to conclude that state quarters have a weight different than 5.67 grams? So let's kind of go through a few things. We always have to start with a null and alternative hypothesis. We are talking about, is this talking about a mean or a proportion here? This is the mean, so we're talking about mu. My null is that the mean is the 5.67 that the Mint says. My alternative, I want to know if it is different. What's
Not equal to.
not equal to? So this is a two-tailed test here. All right. How many degrees of freedom do we have in this problem? – 17. We had 18 points, so that means 17 degrees of freedom. Now in the problem we did yesterday, we started out by finding the t value, which is kind of like a mean, or sorry, kind of like a z value. So it's our mean minus the mean we were told divided by standard deviation. But the problem is, if I have this data, I don't have the mean and standard deviation available to me. I need to find those. So what should we do first? Okay. Why don't we, since we're going to have standard deviation too, let's go ahead and just do it on the calculator. So you're going to go to Stat, Edit, clear whatever's there, and enter all this data in your L1. So from here we have some different options. We could get the actual mean and standard deviation and find our t by hand. We could also use our calculator to do it. Can I go ahead and walk through the doing it by hand just to kind of help us understand it a little more? But I did tell you that for the most part we will do a lot of this on the calculator. So how did we get the mean and standard deviation from this? Stat, calculate, one variable statistics. Your list should be L1, you shouldn't have anything in frequency list, and calculate. So when we do that, it tells us the mean is 5.7022. We want this is a sample, so the standard deviation is the S, so 0.0497. Okay, so that's for this data, which most of the problems that you're going to be given, this stuff will be given to you in the problem. To get a t-value, you need the mean and standard deviation for mu. If you look on your formula sheet, under chapter 8, the first bullet, the mean for x bar is just mu, the one given in the problem. The standard deviation for x bar is our sample standard deviation from up here divided by the square root of n. So we get 0.0117. So if I asked you to find your t, that's our value, 5.67. Sorry, not our value is 5.7022. Minus the mean, 5.67, divided by the standard deviation, 0.0117. So we get a t of 2.75. What this means this is my t right here. Since it's two-tailed, we would also have a t down here, right? It would be a negative. All right, so the critical region is these two tails. Essentially what happens is if you fall in these tails, we would reject. Okay, that's going to be our unlikely region. If you're in between those, it's okay. And the reason I had two tails is because my alternative was not equal to. If it was greater than, we'd only have the one on the right. If it were less than, we'd have the one on the left. All right, if we were doing this by hand, we would have to get the p-value from here. Okay, p-value is the probability of this. So if you were looking at your t-distribution table, how many degrees of freedom do we have? 17. What alpha level did I give you in the problem? 0.05. So if we went to 17 degrees of freedom, now, because it's two-tailed, the 0.05 is split over both of these. So how much does each one get? So to get my p, I'm looking on the table. We're looking at 0.025 our degrees of freedom would be 17. So that p-value is 2.110. Okay, so how does that tell me if I would reject or not?
You're not going to, because it's not greater than or equal
2.110, wouldn't that fall in between these? So if you're in the middle region, you don't reject. If I gotten a p-value of 3, 3 is bigger than 2.75, so it'd be over here, so then we would reject. Okay, that's one way of doing this problem. Are there questions on how we did that? Okay. The other options, we can do things strictly from the calculator. So I would like to do one from the calculator and kind of stress that. And I'm probably going to add some examples on this one as well. So this one we would fail to reject because it's not in our shaded region. Sometimes in a really large sample, we might get that we would reject, but it really doesn't have a practical significance. And I'm going to show you a case of that where we might get to reject the null hypothesis, but it really doesn't mean much in doing so. So the example I have, maybe. In 2003, the average age of a mother at the time of her first childbirth was 25.2. When I say average, that's already telling me I'm talking about the mean here. To determine if the average age has increased, so I could probably write my null and alternative hypothesis right now. My null is that the average is 25.2. My alternative is what? Increase would be greater than. A random sample of 1,200 mothers is taken and is found to have a sample mean of 25.5 with a standard deviation of 4.8. Determine if the mean age has increased using alpha equals 0.05. Okay, so let's talk about doing this one on the calculator. If you look at my sample size, 1,200, is my table going to be very useful here? No, my highest degrees of freedom is 1,000. I'm not going to be able to get very close from my table anyway. So let's talk about doing this just from our calculator. So remember, I did kind of walk through one on the calculator yesterday. We had to go to stats, tests, and we want number 2. A t-test. Okay, we have the two options of data or stats. The previous example where we entered everything in L1, you would run it off data. Here though, we actually have the stats. Mu sub 0, that's the mean of the null hypothesis, so that's 25.2. X bar, that's the mean of my sample, which was 25.5. Standard deviation of X was 4.8. N was 1,200. We are testing greater than, and I want to calculate. Okay, when you're doing it on the calculator, it would be helpful to me if you would write down a little bit of information. You don't have to put everything, but I would like if you would write down your t statistic. So our t was 2.165. What do we get for the probability? probability is p, so 0.0153. All right, when we're doing it on the calculator, how do we know if we reject or not? If your probability is smaller than alpha, you reject. Okay, so when I look, my probability, 0.0153, is less than alpha. So we reject the null hypothesis. So what does that mean? That means that there is enough evidence to conclude the mean is no longer 25.2. Significant? Probably not. We were talking about a mean age of 25.2 years versus the sample is 25.5 years. Is that a huge difference? We're talking about age, 0.2, 0.5, you're still 25 years old. You know, it's a few months difference. So it doesn't really have a big practical significance. It's not like saying your age increased from 25 to 30 or anything like that. But all the same, the evidence does tell us to reject. All right. I want to probably do some more. Is that okay with you guys? I know those are the only ones I have on here, but I think you have some room to write in more examples. So let me find another one. Let's do... All right. So I'm not giving you a ton of information here. I've already given you the null and alternative hypothesis. Remember when we're talking about mu, what criteria do we have to use? And n has to be bigger than 30, or I have to tell you that the data is normal. My n is not big enough, but I did tell you that my data was normal, so we can do this. When I ask for the test statistic, what am I asking you to find? T. The test statistic is T. Okay. There's a couple different ways of doing that. You could think of it in terms of a z-value. If you're looking at your formula sheet, it gives you a formula for it, which is written a little bit different, but the same thing as finding a z. So on your formula sheet, where's that? Under chapter 10, it's the second bullet there. It tells you that T is X bar, so 76.9, minus mu, which is 80, divided by S, so 8.5, over the square root of n. If you type it in like this, just make sure you put parentheses around the top and parentheses around the bottom. I got negative 1.711. Part B. Let's say if I said if alpha equals 0.02, find the critical value. Okay, so those are like those problems that I added in at the beginning of class today. It's reading that t distribution. How many degrees of freedom do we have here? 21. My alpha is 0.02. So you go to your table when alpha is 0.02 and 21 degrees of freedom, you get 2.189. Now, what's wrong with that? That's to the right, and aren't we testing to the left? So how do we make it to the left? Just make it a negative, that's all it is. Okay, let's draw this. I think that helps. So if I'm drawing this, we have this number, that's our critical region. And then we know we're doing less than. So basically anything in that we would reject. Was our particular t value in that window? No. So our conclusion, I'll make that part D. Since RT of negative 1.711 is not in the shaded region, we fail to reject. The null hypothesis. The only problems I'm going to ask you to do by hand will be stated out like this. Okay, so most of them we are going to do on the calculator. The ones by hand, I will break it into an A, B, C, D, because I know these are a little more challenging by hand, and this kind of helps us. We find our t, we get the number from the table, we draw our picture, we figure out, okay, if our t is in that shaded part, we reject. If it's not, we fail to reject. Okay.
My calculator is not giving me decimals, it's only giving me fractions.
All right. And then let's just run through one more where I would expect you to do it all on the calculator, and then I'm done. I know this one's a little more challenging, just the by hand versus on the calculator. It's a little bit different. Let's look at okay. Can I read it to you instead of writing it all out? Is that okay? So in 2002, the mean age of an inmate on death row was 40.7 years. If I'm talking about mean, that's our mu. So the mean is 40.7. A sociologist wondered whether the mean has changed. So what would the alternative be?
Not different.
Not equal to if we've changed. She randomly selects 32 death row inmates and finds that their mean age is 38.9 with a standard deviation of 9.6. Okay, so let's decide if we would reject or fail to reject this. I didn't tell you that it was normally distributed. Would we have to? No, because n is bigger than 30. So my criteria is met. N is bigger than 30. We're good there. All right, so this would be one where I would just expect you to do it on a calculator. So if we go through stat, test, number 2, t-test, because we're talking about the mean, we're going to input stats, mu sub 0, the mean of the null is 40.7. X bar, the mean of our sample, 38.9. Standard deviation of the sample was 9.6. N is 32. We are testing not equal. And calculate. So what I would expect you to write down, the mean and alternative, which we did. Let's go ahead and write down the t value here. So we get -1.0607 or -1.061. And then the p, the probability of that is 0.2970. Let's say I need to give you an alpha, don't I? Let's say alpha is 0.05. Okay, we reject if our probability is less than alpha. So do we reject or not? Since the probability is not less than alpha, we fail to reject. What does that mean? It means there is not enough evidence to conclude the mean has changed. I know that I took a lot of time today going through this, so we are going to have a work day tomorrow as well for this 10.3. It's kind of, if you look at your homework packet, they're kind of stepped out like we did. The very first question is just practice finding that critical value, which is the example that I started class with today, just reviewing how to read that t-distribution table. 14, 15, 16, those are the ones where you're working out your t statistics by hand, like the ABCD, like I did. And then after that, they're pretty much all calculator questions. So you can do them all with a calculator. Okay, and you have time